name is Melwin and I'm a student from Christ University. My department is AIML and Data Science, and I'm here to present my capstone project. The problem statement that I've taken is that industrial defect detection. In an industry, suppose we have a conveyor belt with a lot of products going through, and there might be some defects or contaminations with some of the products. If there was a person to inspect them, there will be a lot of inconsistency, and also it will take a lot of time. So instead, I have developed a system in which if there is a camera installed next to the conveyor belt, which takes the images of the products coming through, the AI model can render through the images and figure out if there is a defect or a contamination in the said product before shipping. So the dataset that I've used is the MVTech dataset. It is a standard benchmark for these type of models, and I focused on bottles, glass bottles specifically. So moving on to my project. Here, you'll be able to upload a image of the bottle. This image is taken from the top, and you can see the inside of the bottle. Here, this is contaminated image. As you can see, there's a bit of dirt which the model picks up. The model that I've used is the ResNet 50. The reason I use that model is because it works well with small amount of data. I've only had less than 100 images train my model, so I've used this model specifically, ResNet 50. And as you can see, the model picks up a grad cam. It shows where the model is focusing on. You see the red and yellow patch, that is where the model is currently focusing on. And with this, it moves to the LLM, and which gives a report. Here, it has detected that it is contaminated with a confidence score of 99%, and it forms a report, a maintenance report, which includes a small summary of the confidence level, the severity, the description, probable root causes, and also actions that we can implement to correct this defect. Now I'll show you another example. I'll show you a good model. I've divided my models into batches, and I'll take a good model. And it will render. As you can see, it has detected no defects with a confidence score of 78%. And you can see the LLM also has made a report, maintenance report reflecting the same. And you can also export this as a PDF for later uses. Now, the honest limitation to my model would be that we need specific images of the products. Suppose in the case of the bottle itself, we need a specific image of a top-down shot with the proper lighting. If that is not reflected the image, the model may not, or to a certain extent, will not be able to classify if it is contaminated or a broken or a good product. The solution to this problem would be more data. If we are able to collect more data of different images from different angles of different products, we'll be able to train the model to a certain level of accuracy, which will help us to remove this limitation. So that is my capstone project, and thank you.